Alright, student, let us start today's topic, that is mathematical reasoning. Again, it is one of those topics which is very easy to do, and generally we people are very, we are not confident about this particular topic because we haven't practiced it thoroughly. So we'll be taking this chapter today because a question will be almost probable to be asked in the examination. There are 90% chances that a question will come on mathematical reasoning. Alright, so that is why I say this is important, because it will fetch you straight away 4 marks. So let's start with the basics of this particular chapter. So the entire chapter of mathematical reasoning is based on statements, right? So what do you call a statement mathematically? A statement is called a mathematically acceptable statement if it is true or false, but not both. So a statement over which you can debate, that is basically a line over which you can debate, is basically a statement in maths. Whether it could be true or false, that depends, but it cannot have both the properties that it is true and false at the same time. So if you talk about if you can see, we are talking about the truth and false of a statement or the validity of a statement. So it is simply acting as a binary figure. People who are having computer science will be able to connect better. So binary, because why? Because there are two options particularly for every statement, that is true and false. Either it will be true or it will be false, or if you want, you can denote binary by something like this. Alright, just to give you an idea of how computer science is being attached with this particular chapter. To go further, what is not a statement? Let's just do that, because some examinations ask these very basic questions. So imperative sentences are not statements. Imperative, that means their command or their request. Okay, this should be request. Exclamatory sentences which express feeling. Interrogative sentences, that means they are asking some questions. They are not considered as a mathematical statement. Believe me on this, right? So you have to remember this as a property. This is the property one, that what you call that these statements are not statements. So for example, give me a glass of water. It's a request, right? It's a imperative sentence. So this is not a mathematical statement. Is every set finite? Again, it's a question, right? Interrogative. So it's a question, that is why we will not say that it is a statement. How beautiful? Again, it's a question. So questions are never your statements. Sentences involving variables such as today, tomorrow, yesterday are not statements. Another property 2. So the statement which involve today, tomorrow, yesterday, again, for example, here is tomorrow is Monday, so they are not again statements. Alright, because we will not talk about the validity or the truthfulness of this particular sentence. Got it? Okay, let's move ahead and talk about the truth table. So as we did that every statement that we take in math can have two values, right? A statement has two values. What are they? Yes, either it could be true or it could be false, right? So if a statement is there A, so what we do generally, so let's say there are two statements and there must be some relation between them, which we are going to study in this particular topic. So there are two statements, let's say A and B. So how you can actually judge their validity is, both of them can take two options, right? 2 and 2. So how many total options can be there? Again, it's a question of P and C. Yes, so there could be 4 total options. How we are going to draw it is basically a truth table. So you draw A and B in 2 columns, right? And then start filling the tables. In what fashion you will do, let me just show you. So for example, if you are starting with A and there are 2 variables, so number of rows, so I have written the formula. So number of rows in the truth table is equal to 2 raised to power n rows are there. So here, how many statements are there? 2. So what you will say, there will be 2 raised to power 2, that is 4 rows will be there, right? So 4 rows, so divide 4 by 2. Yes, that is 2. So put 2 T's and 2 F's like this. This completes the 4 rows. So 2 T's and 2 F's. So for B, what you will do? Alternate T and F. Alternate T and F. Right? And there will be some conclusion over here. We will talk about later. So this is how you construct a truth table. Construction of truth table. Basically, that is what we have done. So let's say if I take, there are 3 variables. Okay, let me take 3 variables for you people. A, B and C. So how many rows should be there? 8 rows for 3 statements, right? So 3 statements. So what you will do, 4 T's starting, then 4 F's, right, for A. Then for T, what you will do? Yes, here were 4 T's. Now you will have only 2. Combination of 2 T is 2F. This is the pattern that you will follow. And then again, there were 2. Now divided by 2, so only 1. So alternate T and F for C. So this is how you construct a truth table, and this process could go on, right? So this is the construction of when there are 3 statements given to you in the question. I hope the construction of the truth table is clear to you. So you have to start with truth and then false, right? This is how you go. Okay, now let us talk about negation. Now we will talk about what particular operations we can do on statements. So first one that we have to do is the negation. So negation of a statement. You can understand that as negation of a statement. Negation, as the name suggests, it is coming from the word negative, right? This is coming from the word negative, and if we talk about in real terms, negative means opposite. This is how what you can understand, opposite statement, right? So if A is a statement, then how do you express the negation? So mathematically you express this as this sign A. So this is A naught, right? Remember A naught we used to say. So this is negation A. We do not say A naught in this chapter, we say negation A. So what happens here is that if you have A, and if I construct the truth table, so it will be T and F, right? It's only a single statement. So what will be happening with negation A is, if it is true, then negation will be false. If it is false, then negation will be true. This is what is meant by negation of a particular statement. It's very generic. What we will be now doing is that we will taking negation to compound statements. Okay, so let's see how negation works in the compound statements as well. Okay, before going further with the negation usage in compound statement, let us first of all study what are compound statement. The first compound statement that we have to do is AND operator. The AND operator syntax is this. So if there are 2 statements P and Q, so P and Q in mathematically is written something like this, P and Q. What does this mean? That it returns true, it returns true, or you can say this machine works only when both P and Q are true. Both P and Q are true. Otherwise, in all cases, it will not work. Otherwise, in all cases, it does not work. In all cases, it doesn't work. It is that kind of machine. It does not work. So for this machine to work, you can understand it as a machine system. For this composite machine to work, both P and Q should work, and by work I mean true. So let me just draw the truth table for this now. So P, Q, and you had P intersection Q. That is what your target is. We know how to draw a truth table now. So for truth table, what you will do? T, T, F, F, and for this will be T, F, T, F, right? Now if both of them are true, then the value of P intersection Q will be true. Apart from that, if any of them is false, the answer would be false also. If any of them is false, for example here both of them are false, the answer is false. Here this is false, answer is false. Here this is false, answer is false. So it is only true when both of these statements are true. That is the meaning of A and B, or P intersection Q, or P and Q. The next compound statement that we have to study is the OR. So for OR, what is the connector that you use is the opposite of what we did in AND. So if you want to say P or Q, this is how you will write mathematically, P or Q. So what does this mean? When will this be true? So if somebody asks when this will be true, so it's the answer is again simple. This will be true when any of them is true. Any of them is true. This is the answer. So let me just show you with the help of again the truth table. So if this is P, this is P or Q. So again we'll start with P with F, sorry, not with F, we'll have to start from, we'll start from T. Though you can start from F also, that is not a problem, but we'll maintain the symmetry that we have talked about. So TF, 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 TF. So P in union Q, in a way you can say that the sign but it is not spelled T union, it is P or Q. So here both of them are true, obviously true. Here P is true, but Q is false, no problem, it is true. Here there is one T, true. Here both are false, now the answer will be false. So now you can compare that if I just draw P intersection Q or P and Q again, so P and Q was true only when both of them were true. So this was the truth table for P and Q. This is the truth table for P or Q. Right? These are the very basic stuffs that you people have to remember. Now let us see how we apply negation in compound statements or compound connectors. So, and we will use De Morgan's law for these kind of activities. The formula is that if you negate P or Q, this is how you will write it. So negation P or Q will be nothing but negation P. Change the connector also. You change the connector and put the negation sign on Q also. So for example, if something of this sort was there, negation of negation P or Q. So what you will do? Negation of negation P, intersection or sign, and then negation Q, which reduces to nothing but negation of negation will again give you, yes, P and negation Q. So this could be written like this. Similarly, if I talk about the negation with the and sign, so if you are negating P and Q, so this will be nothing but negation P or negation Q. And if I want to take another example where something of this sort is there, so what you will do? Negation P, negation of this sign will be opposite, negation of negation Q would be Q. So this is how you have to take negations for compound statements. I hope the concept is clear. Let's take negation of this compound statement, which is a bit lengthy one. So let me just write the compound statement for you. So this is the first statement, which is itself a compound statement, and you are taking its and with this particular statement over here. You want the negation of this, right? So just treat it, don't worry, this is A and this is B. So what is negation of A and B? It is nothing but negation A or negation B. So what is negation A? Negation A will be negation of negation P or Q. This is nothing but P intersection, or you can say and negation Q. And what will be negation B? Negation B will be negation of negation Q and negation P. So this will reduce to P, sign change, yes, and Q. This is your answer. So you were looking and just put the values over here now. So your answer should be P intersection negation Q union, or you can say or P or Q. This is the answer we were looking for. This is clearly evident in our B option. This is the answer. I hope the concept is clear. It's very basic stuff that we are doing. Let's pick another problem to understand the negation questions. So it says the statement this is logically equal to. So when something like this logically equals to comes up, what you people can do, there are two methods of solving this, right? So let's take method 1, which is a simple approach, that is you draw truth table. So there are two statements P and Q, right? P and Q, and there is another statement, but it is negation of only Q. So let me write P. So if I start with P, so this will be T, T, F, F, and Q will be something like this. Clear? What will be negation Q then? Yes, opposite of this, T, F, F, T. You need to find what P intersect and negation Q. P and negation Q means this will be true only when both of them are true. So this and this false, this and this true. So this is the only truth part that you have, false. This is false and false, so this will be false. False and true, this will be false again, right? And then you want this to have or with, you want this statement to be ORed with nothing but Q itself. So now we will be focusing on our energy on this particular column and this particular column over here. So OR means any one of them is true, then the answer is true. So true false, this will be true. False true, this will be true again. This is true false, this will be again true, and false false, this will be false. So now you were being asked what it actually represents. All right, so we did an error over here that it should be, yes, rightly pointed out, it should be with the P. So this is what we wanted. That is why we were not able to match our particular answers. So this is P. Let me just correct it. So now let me talk about this then. Quickly tell me what will be the value. So you want this and this column, sorry, and you do not want the other column. Let me just again remove that one. Right. So now tell me what will be the answer. So true, false, true, true, true is true again, false, false is false, false, false is false, right? So what it actually looks like, this particular stuff, you have four options: P, Q, negation P, negation Q. So just compare with P. Yes, it actually matches with P. So the answer to this problem is nothing but it matches with P. So this method one that you can do is by drawing truth table. You can just draw the truth table. But if you see that we had put a lot of labor to do this particular problem. So let us first of all try a method where can we simplify this. So method 2, right, where we'll be using De Morgan's law. So it says P and Q, negation Q, and it will be OR with P. So now we know that these laws are also associative and distributive. They are associative, right? They are associative, and at the same time they are distributive also. So what do I mean by this? I'll just show you. They are distributive also. Just remember this. And how distributive property works, just let's see now. So you are given this. If I want to make P inside, so what it will be, P or P, and then this comes into play here, and you will write P or negation Q. This is what you could also solve. So this is what P or P will be nothing but P. P intersection P union negation Q. This is also what you can solve. This is what I meant by method 2. So either you can directly go and solve this, or you can solve like this also. Though if you see, this does not reduces the complexity of the question, but maybe in some question this might reduce the complexity. So what do I mean by the distributive law here is, I reiterate. So if this is given to you, so this is equal to saying A and B, right? You do this operation, union A and C. This is what is meant by this. Or if this was something of this sort, then this will be A or B intersection A or C. So these are the things that you people can also do. Now let's take another question on the composite side. It says if this particular statement, which is given to you like this, that P and negation Q or Q and R is true. This is given to be true to you people, right? And you are also given the value of Q and R are both true. So it is also given that Q will take value true and R will take value 2. Then you need to tell what is the value of P. So understand that P can only be out of these two. Either it will be true or it will be false. So we have a very limited case here. So let's take case 1 to understand this problem. So case 1 says, and we'll assume that, let's assume P is equal to 2, right? We assume the P to be true. Now let's just put in the value. So if P is true, Q is already given to be true, R is also given to be true. Let's put the values in the statement given. So it will be P, true intersection negation of Q will be false, right? This will then become or true intersection true. What it will be? So true intersection false will be false. False or this will be what? Yes, true. And this will be again or operator is there. So or if any one of them is true, its answer is true. We wanted this particular statement to be true, which you are getting. So here it matches with this particular stuff. So that means this implies P is equal to true. This is one of the possible cases. Let's also take case 2 before just not move to the conclusion that P is true. Solve for P equal to F also, because if you see the option C, it says may be true or false, right? It says it could be both. I don't know for sure. So let's put false in now the statement. So this becomes false, right? Intersection with the negation Q is again false, right? Or Q intersection R, this will be T intersection T. This F intersection F is F, or with the A, T and T is T only. F or T will again give you T. This is again true, right? If you see, this comes out to be again true because the statement is true. So that means P can take both the values T and F. So the answer is C. So irrespective, so that means this machine is answering irrespective of P. That is what is meant by this. You could have an answer option as irrespective of P. So this machine works irrespective of P for you people. Okay, let us understand the concept of tautology and contradiction. So what is a tautology? So let's say you are given a statement or a compound statement, right? This is a statement, or let's say a compound statement, it doesn't matter, right? So if it's a compound statement or a statement which is always true, so that means that truth table should have last column, that is the answer to that particular statement, last column should have all T's. So if this is the case, then we will call this particular statement or the compound statement a tautology, where that is, it is always true. And the opposite of this will be contradiction, that is fallacy. You can get both of the words, fallacy or contradiction, where it will be always false. So here the truth table should written will be all false, all F's in the last column, right? This is how you understand tautology and contradiction. So a very simple tautology is which is always true, contradiction is which is always false, irrespective of these statements. And you should also understand tautology is represented by T or capital T, contradiction is represented by C or capital C, right? And we have to understand their formulas also. For example, P or T will give you what? Again tautology. So P or tautology is tautology. P intersection or P and tautology will give you again P only, right? P or C will be nothing but P, but P intersection C, that is P intersection contradiction, will give you contradiction again. So these are four formulas which you people have to remember. They come in very handy, and sometimes we people just get confused between the formulas of this, especially contradiction. Tautology seems to be very simple, but yes, P union, or you can say or C is P, but P and C is contradiction, opposite of what tautology is. Okay. Before going further, let's do some basic properties that we should be very clear of. So for example, if I say P or Q, it is equivalent to saying Q or P, doesn't matter. So the order in which you write doesn't matter. Similarly, if I say Q and P, it is equal to P and Q, one and the same thing, doesn't matter at all, right? Should be very clear to you. Though, let's talk about the distributive law, how distributive law is working in so let's say these are the statements. So what you will do, yes, P and Q if you want at the same time. So this connector will now be taken with everywhere, P intersection R, and now the other operator that was inside, this inside operator now will come outside. So this is how you take distributive law. So this is your distributive law, right? So you can apply this similarly. So this question would be completely similar if it was given something like this, right? This is completely equal because you can switch the P to the front. So don't worry about whether it is the different statement or the same statement. Okay. If we talk about the associative law is also very much valid here. So what do you mean by associative law is you are given the same operators everywhere, right? And you are asked to solve this. You can solve this in this fashion also. You can simplify to solve this first, and then you can take the intersection. And this is also valid when there is OR operator. So if you are trying to solve this, it is equally good to solve the first two and then take the OR operator with the third one. Okay. So if we want to talk about some important results that you should remember, that let's say you are trying P or negation P, what will be the answer? So for P negation P, the answer will be nothing but tautology. Remember this. You have to be very clear about this particular fact. And if you talk P and negation P, that is, you can understand and as intersection or the common output, common inputs. Common, what is common in them? Common, intersection, whatever you want, which makes your understanding a bit easier. So P and negation P will have nothing in common. So here the answer is tautology. Oh, contradiction, sorry. Okay, and similarly, if I want to take with the C, though we have done this, but I'm just reiterating for you. So if this is the case, then what you will do, the answer would be, tell me quickly, yeah, P. And if P intersection C is there, then your answer will be contradiction only. Other important thing that you have to remember is the negation of T is C and negation of C is T. They are again negations of each other. Okay, so this is what you people have to actually remember. So let's say we were given a question to be solved, that is P or negation P or Q. This is, you want to simplify this. So we can first of all use the associative law here. So for associative law, we can change the brackets, right? So I can put the bracket here and I can take the or with the Q again. Now P or negation P is tautology. Tautology with or Q is nothing but tautology. So the answer to this particular problem is T only. This is how you will have to simplify using all the properties that are written on the screen. Okay. Okay, now let's understand a very important part of this chapter, that is implication statements. So what do you understand by implication statement is, that is, they are conditional statements that written over here. Conditional statement. What do you understand by a conditional statement? It is of the form if P then Q. So if anything of this sort is there in English, we call them as a conditional statement or an implication. So if P then Q, so how do we represent this mathematically? This is the thing we represent. So arrow should be towards Q. So this means if P then Q, or you can have this kind of arrow as well, double lined arrow, single lined arrow or a double line arrow, both represents implication, right? So for example, I have taken in English, if ABCD is a parallelogram, then AB is equal to CD. So for this, if I have to convert this into a statement, this statement into mathematical logic, so this is P. If P is there, then this is Q. So this is how you will represent implication for this particular statement. Okay, and if we talk about what answer we will get of P implication Q, this is false only when P is true and Q is false. That the first part, if part is true, but the statement is false, right? The consequence is false. So how you can also understand this is that if P, this is hypothesis, right? This is what you assume, hypothesis, assumption, whatever you want to understand, like, right? This is assumption, and then this Q is nothing but the conclusion, right? So if you want to understand how we want to learn this, that P implication Q, that if P is true, then the conclusion should occur. But if P is occurring, so that means if the assumption is there but the conclusion is not occurring, that means the statement is false, right? Clear? Let us see what is the mathematical logic behind this, or the formula, mathematical formula for this. So the mathematical formula is this, which you people have to remember. This is the mathematical formula. Okay, so for mathematical formula, P implication Q is nothing but negation P or Q. Now we also did that P implication Q is false only when P is true and Q is false. Just quickly see this with the help of your truth table. So P, let's say, was this. I hope now you are comfortable with drawing the truth tables. So you want P implication Q. So P implication Q, I have told you that this is the formula that you will be using. Negation P. So negation P will be what? If T, and then you will take OR with Q. So if you take OR with Q, that means wherever true is there, it will return true. True, this will be false, this will be true, and this will be true again. So if you notice that here there is only one false, and this is happening when P is true and Q is false, and this is what we were saying. So if P implication Q has to be false, it occurs only when the hypothesis is true, but the conclusion is false. Conclusion is not occurring. And you will have to remember this formula, this particular stuff also, right? Let's move ahead and do the implication problem first of all. So it says that this is the statement now that P implication P or Q, right? So this is your hypothesis and this is your conclusion, right? Okay, so let's draw the again truth table for them first of all. P and Q are the two statements that are being used, T, T, F, F, and this will be TF and TF. What other than that this is being used is P or Q. What is P or Q? Tell me quickly. So P or Q will be wherever you will find true, you will answer true, true, true. This is true and this is false. Okay, now you want P implication P or Q. So we know that this will be false, this will be false only when it is always true except when hypothesis is true, that is P is true and the conclusion is false, that is P or Q is false. So we are looking for this particular category where P will be true and P or Q will be false, then the answer will be false. Let's see. So you have P true, this is true, so the answer to this will be true. No problem. We just have to work around this where P is true and P or Q is false. Just look around. You will not find this actually. Why? Because there are only two rows where P is true and for both of them the conclusion is true. So that means this is true. If P is false, then there is no problem at all. You just simply replace it with T. Understand that implication is always true. You accept, remember like this, except is always true, always true, right? Except where P is true and conclusion, that is Q, is false, right? This is the exception. So if you see what we will get over here, yes, this is a tautology. This is what is meant by tautology, where all the rows are true. So the answer to this problem is A. Okay. Okay, let's take negation of implication. So as I've already written on the screen, so negation P implication Q is P intersection negation Q. So you can now, if you remember the formula of this, which we did like this, right? This is not very easy for you people. So if you know this, there is no problem. So negation P implication Q is that you will negate this. And now we know negation very easily, right? This will be what? Negation P is P, negation of OR is and this will be this. And this is the formula again. You will find them in the problems. Let's apply this in particular problems. You can, though, if you want to try, you can try it with using it with the truth table as well. So in case of truth table, if you want to remember, we know that P implication Q is always true except one case, कब? When P is true and Q is false. So what will be the about negation P? So it will be always, yes, it will be always false, yes, except this case, the same, because at this particular stage this will written true and everything will become false. So if I want to negate this particular statement over here, so if it is raining, then the game is cancelled. So if it is raining, so let's say I'll take P only, not A. So P statement is it is raining, right? And let me take Q statement is the game is cancelled. Game is cancelled. And they are expressed as implication because it is given P implication Q. If it is raining, then the game is cancelled. We know that this is nothing but, yes, just, yeah. So negation Q or P. We want the negation of this. So negation of this we just did. What is the negation? Negation of this is P and negation Q. So that means your answer should look like something of this. Now we just want to convert this into English. So if we convert this into English, what it will be? It is raining. It is. So don't put if now, because now it is no longer an implication. So it is raining and the game is, it is negation. So we will use not cancelled. This is how you have to make statements. So it is raining because of P and the game is not cancelled. This is the negation of this implication. Negation of M. And this is how you solve it. This is what kind of problem might be asked to you in your JEE Mains and BitSet level exams. Right? I hope this is clear. Now let's understand the concept of contrapositive. It says if P implication Q is there, then it's contrapositive. First of all, contrapositive is nothing but negate Q and imply with negation P. So you just have to reverse the order with taking negation. Understand that this is not equal to negation of implication. Negation of implication is completely different. Right? It is not equal to negation of implication. In fact, contrapositive is equal to implication. Very important property. Let me just prove it to you people. Okay, so again I'll draw a truth table with using P and Q. Okay, so these are the values of the truth tables. We wanted P implication Q. Let's see. What is P implication Q? We know that P implication Q is always true except when P is true and Q is false. So this is this particular row. It is happening here. So true, false, false, false. Right? Now we will check it for negation Q, implication negation P. So this will also be false. This will be false only when negation Q is true and negation P is false. This will be false. Otherwise it will be true. So negation Q, I have written negation Q here. Negation Q is true here and see P is false. So it is the same row. Can you see? Otherwise it will all be true. So can you see everything is matching? Every column, oh sorry, every row is being matched. That is why I can say that contrapositive is equal to nothing but implication. And you have to remember this. Remember that this is not equal to your negation. This is the formula that you people have to use. So if I have to take an example that this was your statement, if x is non-negative, then x is 0. Convert this into contrapositive. Write the contrapositive of this statement. So let me say that P is x is non-negative. Right? X is non-negative. And then you say Q is x is 0. So the contrapositive will be negation Q, implication, negation P. So how I will say this, if x is, yes, negation Q, negation के लिए we'll use not. If x is not 0, then negation P, then negation P will happen. Then x is, yes, not a non-negative number, right? And then x is not a non-negative. This is what is meant by this. Okay, I hope the conversion was clear to you people. Let's take a problem to understand the contrapositive. So it is given that P implication negation P and Q. You want to find the contrapositive of this. So for me this is A and this is acting as B. What is the contrapositive of A implication B? What is the contrapositive? Yes, you are right, it is negation B goes to negation A, right? So it will be what? Just replace these values now. Negation B will be negation P and Q and implication negation P. You can simplify this. This will be becoming what? Take the negation of this and this will be converted to this. So actually your answer should something look like this. This is the answer we have to match in the answer options. Just look around. Yes, you find that is happening with the D option. So D is the correct answer, right? Don't worry if you are getting confused between a single arrow and a double arrow. I told you that implication can be this also, and implication can imply sign also. So both of them are implication, vice versa you can use them. I hope the concept of contrapositive is used correctly, and you have been able to analyze the difference between contrapositive and negation of a implication. They are completely two different statements. Okay, now let's take the other kind of operator, that is the biconditional operator, and it is something which says if P and Q are two statements, then P if and only if Q. So P occurs if and only Q occurs. This is the statement like that if P and Q are any two statements, then the compound statement in the form of P if and only if is called biconditional. For biconditional we use two arrows. So for implication we use just one arrow, and this will be in both the directions. So the mathematical formula is this particular stuff. Cumbersome to remember, but it will be great if you can remember this, right? You will not find questions based on this, but still I will advise that do remember this. So it is simply negation P or Q, take intersection, and then reverse the order, that is P or negation Q. This is how you have to remember P by condition Q, if and only if. And if you just want to remember the property, it is true only when both P and Q have same value. Okay, so that means if both are true, then it will be true. If both are false, then it will also be true. It will not be false. Now let's quickly do this with the help of your truth table. So these are the basic things that I have already taken. So you want negation P or Q, negation P or Q. So wherever it is true, it will be true. So true here, right? False false will be false, true true will be true, and false true will be true. Any of them is true, then it will be true. P or negation Q. So P or negation Q. This is the two columns that you have to highlight now. True and false, that will be true. True and true, true. False and false will be false, otherwise it will also be true. Now you want the intersection of these two rows. Let's take the intersection. So for intersection or what you can say and it is only true when both of them are true, right? Let me just change the pen. Yes, so this will be false, this is nothing but true, right? True and false will be false. Again you get true and true, so this will be true. So can you see there are true values which are getting T as the answer. This is happening, let's see when. It is happening when both are true and both are false. So just remember that you will get answer as true when both have the same values, same inputs, that both are true or both are false for bicondition. So now let's take negation of bijection and bicondition, and this is something very interesting. So let's say again I say P is a condition which is given A, B, C is an equilateral triangle. This is given, right? Equilateral triangle if and only if. So that means this is something like this, bicondition. So Q condition is if it is equiangular. So what do you mean by equiangular? It is something which have equal angular angle. So equal angles if it is equally angular. So now you want negation of this. You want negation now. So for negation, you will have to remember that formula that we talked about. So what was this formula all about? Quickly tell me. Just see there. Yes, here it is the formula. Just see how we are going to use this formula now here. So it says this is P or Q intersection P or negation Q. You want negation of this entire statement, right? So what will be the negation here? Negation of negation P or Q. This sign will get changed to this, and you will also be requiring negation of this particular quantity. You can just explain to yourself that how we have done this. This is A and this is B. So you are doing A and B and you want negation. Negation will be negation A or negation B, right? This is the simple step. So what you will obtain is P. Negation of OR will be AND negation Q. This is already OR, we have already negated it, and this will be negation P and Q. So this is the negation of bicondition. Now I need to convert this into your statement. I need to convert this back here into statement. This is the mathematical reasoning and mathematical logic converting this into statement. The first says P intersection negation Q. So P is ABC is angular, ABC is equilateral triangle, right? Then you have this connector. This connector is yes, and negation Q. It is equiangular. So negation will be it is not equiangular. Got it? Then you have this particular operator over here. This is OR, and then you want to write negation P intersection or and Q. Negation Q, negation P will be ABC. Yes, is not equilateral. Is not an equilateral triangle. Then you have this particular operator. This is and Q. Q is and it is equiangular. So this is the negation of bicondition. This is the answer that you people will have to check out. This is the particular answer we were looking for. So now let's take truth table question based on bicondition. It says the statement this is this. So the statement that is given to you is that P and Q bicondition negation P. So we are again given P and Q are the only statements, and then we will draw the truth table only according to these two figures, right? So there will be only 4 columns, 4 rows, and then you have negation P also. Let me just take it. Negation P will be what? False, false, true. You want P and Q. P and Q will be true only when both of them are true, which is the yes first row. Otherwise, all of them will be false. Now let's go and see. You wanted this bicondition with negation P. So now we know the formula that bicondition returns true. So bicondition is true when both are true or both are false. This is what we just studied, or both are false. So this is what we have to check here. So let's see. So in these two columns, just check those values where both are false or both are true. So what you can see here, it is false, it is true, false. Here it is false and false. So this will be true, true, false, false, true, false, false. So is it a tautology? No, it is not a tautology. Is it a contradiction? No, it is not a contradiction. So I will say neither tautology nor contradiction is the answer. Similarly, just let's do quickly the other one. It contains both your conditional and implication as well as your bicondition, right? So both of them are here. So let's see how we'll approach this question. How many statements are there? Yes, again only there are 2 statements. So just focus on how many statements are there in your particular problem. So again we'll draw only 4 columns because there are only 4 rows because there are only 2 statements. Now you want implication with negation Q. So let's do negation Q as well. So negation Q will be nothing but FT, and you eventually want to take something with this also, right? So let's take this also. What it would be? So P and Q will be true only when both are true, and remaining will be false. We know this. Now let's start with this particular stuff. P implication negation Q. So for implication we can again revise. For implication we know that if A implication B is there, this is true except when it is not true, except when A is equal to true and B is equal to false. Otherwise it is always true. So let's look out for those points. So where P is true and B is false. So now you will have to look at at this particular table. These two are the ones which have to be looked on, not look at Q. So P implication negation Q will be false when P is true and this is false. So this is happening in the first column itself. So for this you will write what this is false. If this is true, this is true, false, that the story is over. If it is false, A is false, then you will have to say it is true. Okay. Now you want what? You want this to be biconditional with this. Now let's look to the final answer. You have already calculated this. Now you want biconditional with. Now we understand of biconditional what? It is true when both have same values. Just understand it this way: when both have same values. So how you will solve this? When both have same values, let's check out. T and F, different values, false. FT, false. FT, false. FT, false. That's it. And if you see all of them are false, that is why I'll say this is contradiction. This is the answer we were looking for. So B is the answer. That's it. I hope the question and the concept is particularly clear. These kind of questions could be asked in the exam because it is using both implication as well as your bicondition. Now let us take the other topic, that is argument and its validity, or you can say validity of an argument. So what do you mean by an argument? Argument is said to be valid if the conclusion is true, whenever all the hypotheses are true. So here S1, S2, S4 and these up till all these things are your hypothesis, right? And let me just write, these are your hypotheses. So hypothesis, you people can understand that they are nothing but you can say assumptions in a way, and this is your conclusion S. So if something of this sort is written, so you can say this is the syntax. This is the syntax of how we write an assumption, syntax for assumption. Okay, so this is the syntax for assumption. S1, S2, S3 up till Sn and then a semicolon with S. This is how you write an assumption. Okay, there are hypothesis and this is the conclusion. So when this conclusion would be true, when this particular implication written over here is a tautology. If this comes out to be a tautology, then your answer to the argument is always valid. This is how you check the validity of the argument. Let's apply this particular concept into the problem. So the question here given is that S1, S2 and then you have a semicolon S. So that means this is a argument where S1 and S2 are your hypothesis. This is how you will have to treat them. Implication S. So this is the statement that you will have to check for tautology. If this comes out to be a tautology, right, then your answer would be a valid argument. So for arguments, what you people have to do, just go back and see that all the statements or the hypotheses were taken with the AND operator, right? They were taken with the AND operator and then implication and then conclusion. Okay. Now let's start doing this particular problem then. So you have S1 given to be P or Q. You have S2 given to be P and S is given to be Q. So again there are only two statements P and Q. Just let us draw quickly the truth table. So this is the yes. Now you want S1. So S1 is, let's say S2. So this is S2, negation P, right? Negation P is F T T. So we have already got the S2. Then you wanted S1. So let me just change the pen for S1. So S1 is I highlight here, and this is S2 that you have already calculated. S1 is P or Q. So what is P or Q? Whenever it is one of them is true, it is true, right? True, true, and this will be false. Okay. Now you want what? S1 intersection S2. So you want here S1 intersection S2. So what is X1 intersection S2? That means AND with these two rows. Let's take AND. So AND is nothing but when both of them are true. False, false. This is true and this is false. So this is what you people have got for S1 intersection S2. Now you want S1 intersection S2 implication S. So what is S? S is given to be Q. So this is your S. What do you understand by implication? implication is true for all values except, remember quickly, yes, it is true for all values except when, yes, you forgot. So this is true except, remember I told you, when A is equal to true and B is equal to false. So let's check out these kind of scenarios. Here the role of A is this and this is your B. So A is this, it is true, and what is the value at true you are getting? For B it is true, so it is true, and except whenever A is false, you no need to check, you just simply put T. If your A is false, no need to worry, because you just need to check when A is true, what is the value of B. If B is true, it is true, but if B is false, then it is false. What you are getting here is a tautology. Can you see? That implies it's a valid argument. That is how you solve argument problems. It is a valid argument. That's it. Question over. I hope the concept in the question that I have taught is clear to you. Okay, now let's take another problem to validate the argument. And if you see that here the argument is already given in the statement form. So this is your hypothesis 1. This is your hypothesis 2, and this is your conclusion. Right? You want that this particular statement, if this comes out to be a tautology, right, then this will be valid, otherwise it will not be valid. Okay. So I've taken the basic truth table again. You want first of all the statement 1, let's say S1 is your hypothesis 1 is P implication Q. We know P implication is false only when P is true and Q is false, which is happening here. So this will be false and all the others will be true. S2 is what? Your negation Q, which we have already written though, right? Let me just repeat it for you people. You want the intersection of S1 and S2. So S1 intersection S2 would be what? Yes, so these two rows will be intersected, or and. So and is true only when both of them are true. False, false, and this is last one is true. Now you want this implication with, you want the implication of this with negation P. Let me just write negation P here. So it will be false, false, true, true, and now you want the last row to be, or last column to be, S1 intersection S2 implies S, remember? So implication, again implication is true for all values except when this is true and this is false. So this is true in this particular statement. S1 intersection S2 is true only for the fourth row, and in the fourth row you have answer true, so this is true, rest all are true. So this means this is tautology, right? If this is a tautology, this implies this is a valid argument. That's it. This is what we wanted to solve in this particular problem. Just remember, again I am repeating, that if A implication B is there, it is always true. It is always true except the case when A is equal to true and B is equal to false. So just look out for those values of A where it is true. So similarly, like here I just checked for this particular value, and then I moved to the other part that says true. It is not false, that means it is true, and if it is false initially, just quickly replace true here. This is how you can easily solve them. Okay, let's take the other concept, that is the duality of the statements or dual statements. So the compound statement S1 and S2 are said to be duals of each other if one of them can be obtained by replacing and by or by and. So if you are given two statements where you can obtain them by replacing their signs and they are equal, then they are duals of each other. The connectives and or are also known as duals of each other. Very important stuff. Okay, how do you write dual statements? So if S is a statement which uses P and Q, it's a compound statement given by this. So then S star, if you use the word star, I've written over there already. So S star P Q will be nothing but you replace the connector with its dual. So this is the dual. So this actually, where this is meaning, this gives you the hint that it's a dual statement. So S star is nothing but a dual statement. Very simple concept. Let's try and understand by just putting dual statements of a given statement. So what you people want to do here is you want to write duals of each and every statement written over there. So this is, we want to write dual, right? Let's say what is the dual of this. Do not take any, there is no problem with the negation sign, don't change it. So negation P as it is, then yes, you will have this operator will be changed to this operator, right? This operator then would be changed to OR operator. So only it's the case of operators. This operator will be changed to this, right? And then Q, and then this operator will be changed to this. So this is how the dual has to be achieved. Let's take the other one. Remember, this C here is not a statement. C is nothing but equal to, yes, it is contradiction. So now very important rule in duality. So if you want to dual this, right, duality of contradiction is nothing but tautology. So you will have to now replace contradiction by tautology, and tautology in duality will have to be replaced by contradiction, and this is a vice versa game. So here what will be the dual of this is P and Q. This and will be replaced by OR, but C will now go back to T. Very important, remember this, right? And similarly if I talk here, so P, this T again here is tautology, right? So this T that I'm talking about, this is the T. So this T is tautology, then this will become P and yes, C, right? This will be OR and R. This is how you are going to check the duality. And if you want to further simplify this, we know that P intersection contradiction is nothing but contradiction itself. Contradiction or R is nothing but R. So dual, if you want the dual of this, so dual of this statement should actually match something like this. Again, a very important step. Okay, you can also further reduce this. If you want to solve this, what will be the answer then? You have P and Q or tautology. So what is A or tautology? Can you tell me? What is A or tautology? This is nothing but tautology always. So the answer to this particular problem, the dual of this is nothing but always tautology. This is how you can simplify these statements. So by this we come to the end of this particular chapter. So again, a very important topic as per se your JEE Mains, because I believe it's a very scoring topic. You would easily get 4 marks for just within 45 seconds. So which is something really very important that you score. Just go through the video again and again, watch it completely, solve the problems. I will be mailing the worksheet as usually I do, and just solve the problems. Also what you can do is that you can solve the past year JEE Mains problem. So you will understand what kind of questions are being asked, and that will be more than sufficient, that I believe. Alright, so I'll see you with the next chapter tomorrow. Till then, good night. Take care.